Okie dokie. Welcome to lesson 6 of my physics tutorial playlist, and today we're going to be moving on to our very first actual physics topic. And this is what we call kinematics. And kinematics. So what kinematics is, it is basically the study of moving objects. We know kinesiology or whatever it is. Whenever we have kine, kind of, I think it's due to the movement. So basically, kinematics is the study of moving objects. Okay, so that's basically what kinematics is. So, the very first thing that we're going to define in kinematics is something called position. Now, position is basically what it says, your everyday life position. Position is basically the object's position, really, where it is in the world. Like, where are you? Like, each object has a position, but when you define position, it has to be relative to something. So, in order to define an object's position, we need three things: 1, 2, and 3. So the first thing we need is the origin. So where is this object? Where is this object compared to the origin? Like, where is the reference point? Where is this object relative to this place, to this origin? Second, we need its distance from the origin. So how far is it from the origin? And lastly, what we need is the direction. And we know that since we're dealing with the vectors and all that, we need which way is it? In what direction is this object from the origin? So direction from the origin. And these are the three concepts that we need to define an object's position, right? So this is all three we need. So for example, oh, by the way, the symbol for position is just the lowercase d. Now there are different symbols for this, but the one that I use is the lowercase d with a vector hat, because it's a vector. Because we're dealing with the magnitude here, and we're dealing with the direction here. So that means we're dealing with a vector. So this means position. This lowercase d means position, and this equals, like, for example, this can equal 3.5 meters, let's say, north from the origin. So what have we got here? We know that the origin, we're saying the origin is at 0 meters. We assume the origin is 0 meters. Distance, we've got the distance from the origin, which is 3.5 meters, and the direction, which way is it from the origin? Which direction is it from the origin? Well, this point, this position D, is 3.5 meters north of the origin. So we can label this. So we've got the magnitude here. Remember how we defined a vector? We've got the magnitude here, and we've got the direction here. And this is all we need. And this is a vector because it has a magnitude and a direction, and it fulfills all three criteria for defining an object's position. Okay, so that's simple enough. Now the next thing that we're going to define is something called displacement. And now I'm sure you've all heard what distance is. Distance, we can define distance as the separation between two positions. So let's say we have a point here and a point here. The distance would just be from here to here, right? That's distance. And remember, distance, remember in the previous videos we've talked about, distance is actually a scalar, meaning it has no direction. It only has a magnitude, so it only cares about the length. However, displacement is the vector form of distance, and it has a magnitude and a direction. So let's define displacement. So what is displacement? We can define displacement as the change in position. So remember, change in, or separation, change in position and this is irregardless, so it doesn't care. It does. So basically, the object's path does not affect. So what route the object takes to get to this final point doesn't matter. The displacement only measures from the final to the end, like the straight line from the final to the end. And I'll explain more about that later. So this is what. So basically, displacement is, and the unit for this, and the symbol for displacement is change in, because it's a change in position. And what's position? D. So it's a change in position. And the formula for this is final position, because we know that change in means the final minus initial. So position, final position minus initial position, and I'll denote these by the final F and the I, which stands for initial. So this is the formula for displacement. Okay. So so what do I mean by this? What do I mean by the object's path does not matter when calculating displacement? I'm going to give you an example. Imagine a runner running around a track. So this is the track that run around, and let's say the track's about 2.4 kilometers long, right? The track's 2.4 kilometers long. So let's say some guy Bob, he starts from the start line, runs all the way back here to the end line, and we can say that his distance traveled was 2.4 kilometers. However, what is his displacement? Now, if without this lesson, you guys would probably say, or without any prior knowledge of physics, you guys would probably say that his displacement was 2.4 kilometers, because you guys would assume that displacement is the same as distance. However, you're wrong, because remember what I said, the object's path doesn't matter. You're only dealing with the final and the initial. And the final here, if we call this the start and finish, we call it start 0. The final is also 0. So let's try and find the displacement. What's the final position? It's at 0 minus the initial position, which is 0, which becomes 0. So if a runner runs around a whole track of 2.4 kilometers, his displacement is actually only 0, because he's back at the same spot. And this is a key point, because displacement doesn't care about what route you take. You might have gone this way and that way and all that kind of stuff. Like if you've gone through a maze and ended up in the same spot, it doesn't matter. His displacement is still 0, because you're only dealing with the final and the initial. The path that he took does not matter. So let's try a few examples here. Okay. So let's say a car moves from a position of 5.0 kilometers north from, like, so let's say we are given some sort of a coordinate plane, and he's somewhere here 5.0 kilometers north. So from here the car travels to a position of 25.0 kilometers north, right? Calculate the car's displacement. So find displacement. So formula again. Formula is change in D equals to final position minus initial position, which equals to final, which is 25.0 kilometers north. Oh, forgot one thing. When we're dealing with these kind of questions, we need to define which way is positive and which way is negative. So let's say it's easier, right, in this question, because both directions are north. So let's define the up direction, or the north direction, as positive. So that means that south is negative. So 25.0 kilometers minus in the initial, which is 5.0 kilometers north. And notice that we didn't need to put the north in here, because we already defined here that north is positive, so we don't even need this here. So it's 25 kilometers minus 5 kilometers equals, so its total displacement is 20.0 kilometers Now, the final answer, we can put the north in just to clarify to the user what the final answer is. So his total displacement was 20 kilometers north. So he traveled somewhere here. So he traveled from 5 kilometers to a position of 25 kilometers north. And that's basically it. This is all you need. Now, what if he traveled from 5 kilometers north to south? Let me just delete all this away. Try and delete it properly if I can, if I even can do it. It's a bit messy. Oh well, yeah, we've got a pretty good place right here. So what if instead of north, we have him the car travel from 5 kilometers north to a position. Remember, not displacement. This is his position from 5 kilometers north to a position of 25 kilometers south. So if I drew a reference like a plane, like coordinate plane, he would start from somewhere around here to somewhere around here. So we know it's going in this direction. So just to check back, we can have a visual representation of what it will look like. So again, let's define which way is positive. So I always like to define east or west as positive. I mean, east or north and east as positive. So just a general rule of thumb. I mean, there are exceptions when using south as positive is way easier, but in this case, normally I prefer to use the north direction as positive. It just makes sense to be consistent. So yeah, so we know that north is positive and south is negative. So again, let's use the equation for displacement, which is final position, remember this is position, minus the initial position. And final is what? It's 25.0, but remember it's south, so it has to be negative because south is negative now, because we define from here that north is positive. So that means south is negative. Minus initial. Initial is what? 5 kilometers north. And north is positive, so we just leave it there. So total displacement is negative 30.0 kilometers north, because north is still positive. And this makes sense because negative 30 kilometers north is the same thing as positive 30 kilometers south. Because if we're traveling negative 30 kilometers north, it's the same thing as traveling 30 kilometers south, because negative means opposite direction, right? So the opposite of north is south. And that's basically it for displacement and position. So hope you guys liked it, and next episode we're going to be moving on into velocity and speed. See you guys then. Peace out.